Hello, guys. Welcome to Cheenta School of Statistics and Data Science. We are a team of extremely passionate teachers, researchers, and statisticians from the top universities of India and USA. Our mission is to help you curve your career in statistics, data science, and machine learning. How do we do that? Number one, we help you build your foundations. We achieve that by making an optimized plan for your learning journey. Number two, we help you prepare and ace your entrance examinations in statistics and data science, like IIT JAM MS, ISIM Stat, and CMI MSc Data Science. Number three, we give our absolute best to help you design your career by organizing workshops and certified data science courses. To book a trial class for your preparation courses of IIT MS, ISIM Stat, and CMI MSc Data Science, check out the first link in the description below. If you're enjoying the video, show some love by liking the video and subscribing to the channel. We welcome you again to this passionate community of budding statisticians and data scientists. Let's enjoy the rest of the video. Stay tuned and stay blessed.
Now, next what? So this is how we define a function. So the first question is, we've answered that. The next question is that, so remember we define it like we denote it by an, okay? So next question is that, okay, what is the function? Next question is that we're interested in what? We're interested in the long-term behavior, okay? So the question number two is that mathematicians thought that, okay, how to define a long-term behavior? What we are interested in. So they wanted to find, so essentially this is how um, things evolve in science, okay? It's either experiment to abstraction. So 80% of the time it happens, experiment to abstraction. So what is experiment to abstraction? This is like abstractions or law or theory, okay? So if you see all throughout the history of science, this is has been the only guiding, 80% of the time it happens, otherwise like they predict something like this from here. For example, this was done, it's very hard, this was done by Ramanujan thing. So Ramanujan's mock theta functions were predictions of black holes, and that's what are used now. So these are hard to do, okay? This is not easy, but this is how we learn. We observe from nature, or we get experiments, we see examples, and then we get theories. So can someone tell me what are the experiments in mathematics? What are the experiments in mathematics? This is something important to know from a philosophical point of view, because you understand. What are experiments in mathematics? Can someone tell me? Okay. So experiments in mathematics is nothing but playing with numbers and seeing the pattern. This is what the experiment in mathematics is all about. So what they did is they were trying to understand the limiting behavior, so to see examples. So that you see that if you take f of n to be 1 by n, it was going towards 0. It was going approaching 0. Okay. If you even draw it, you will see it's approaching 0. So then you understand that, okay, so what is the meaning of this approaching 0? So they called it limit. So the question is that, how do you define a limit? Limit of a function, of a sequence. So okay, so let's try out with this example. So essentially the basic idea is this. Understand this term very well. The basic idea is this, that we are given f of n or an. The basic idea is this, that as n increases, I'm writing in code language so that it's short. As n increases, n should be getting closer to its limit. Now let's see where the mathematics can come in, which words can focus on the mathematics. So that is getting closure, this part. the an part as n increases this part and this limit. So let's call it limit L. We need to say getting closure, we will see. So we will see what we are meaning by this. And the n is already defined and n increases, we will see how we do it. Okay. So what they did is this. So they did that they defined like this, that n is a sequence. It goes to this, like its definition is this. That means, so understand there's a dynamics here, that something is approaching towards something and something is getting, changing. Every single step, everything is changing. And that's the beauty of it. That's the dynamics of the whole definition. That something is changing every single time. So what's that changing thing? So we are trying to understand that. So as n increases, okay, as n increases, so we cannot define like this, that as n increases, let's say as n increases, we cannot say the distance. So how we can define it? We can say that an minus L, this is the distance, right, between an and L, or let's say the modulus of it. This must go to 0. But again, the question must come that what does this mean? Like going to 0, essentially the same concept. So like question is that an going to L is equivalent to us saying that an minus L is going to 0, right? So the question is that what is meant, like we cannot be, it's a round circular argument, right? So we need to do it in a different way. So what they did is the following. They brought a dynamics to it. How did they do it? Is that, so understand there are two things. One is n is also increasing and the distance is also distance is decreasing. Okay. So what they did is that they fixed a certain distance. So what they did is the following. So it's like they fix an epsilon. They fix an epsilon. The epsilon is nothing but a strip of length around the limit. The fixed epsilon. And what they did is that they told that there exists, for this epsilon, there exists an n epsilon, like certain integer, certain natural number. This natural number is nothing but the index. It will show that n is increasing. Okay. Belonging to natural number, such that, so in some sense what they're doing is that they're fixing the entire thing. Each definition, this dynamics, they're fixing in every single step, and they're it's like if you have done computer science, it's like they're fixing every dynamics. If you're trying to run a for loop, it's like they're fixing every step and then they're running a for loop. It's like similarly like that. Okay, you will see that. So they're fixing epsilon, and they're saying that for that epsilon there is an epsilon, like a natural number, such that for all elements of the for all indices after n epsilon, the distance between the value of an and L is less than epsilon.